Hello, so today we're going to be solving a mock test for calculus and differentiation. This is related to higher level maths, topic 5. So let's begin. So part A says find dy over dx for the curve y equals 1 over 1 minus x, where x is in R and x is not equal to 1. Alright, so to differentiate this, we can write this as 1 times 1 minus x to the negative 1. As an exponent of negative 1 means that we are dividing by this. So next, to find the derivative, we can say that f prime of x is equal to negative 1 times 1 minus x to the negative 2. And then using the chain rule, we multiply by the inner function's derivative, which in this case would simply just be negative 1. And these negative ones cancel off, leaving us with 1 over 1 minus x squared. So part B says determine the equation to the curve at the equation of the tangent to the curve at the point x equals 3 in the form ax plus by plus c equals 0. So we know that in the form y equals mx plus c, m is our gradient, and in this case our gradient is our derivative, so y would be equal to 1 over 1 minus x squared, x plus c. We know that x is equal to 3, so we can write this as y equals 1 over 1 minus 3 square times 3 plus c. Simplifying this further would result in y equals to 1 over 4 times 3 plus c. So y equals 3 over 4 plus c. Now we just have to find f of 3. So in this case, we're finding it at x equals 3, so we substitute 3 into this function, which gives us negative 1/2. So we have negative 1 over 2 equals 3 over 4 plus c. So therefore, if we do negative 1 over 2 minus 3 over 4, we get c, which gives us negative 5 over 4. So now we have the equation y equals 1 over 4x minus 5 over 4. But we need it in the form ax plus by plus c equals 0. So we just multiply everything by 4 to get 4y minus x equal plus 5 equals 0. So this will be the answer. Let's move on to the next question now. Question 2 says a tranquilizer is injected into a muscle from which it enters the bloodstream. The concentration C in milligrams per liter of the tranquilizer in the bloodstream can be modeled by the function C of t equals 2t over 3 plus t squared, where t is greater than or equal to 0, and t is the number of minutes after injection. So part A says write down the concentration of the tranquilizer 3 minutes after injected. So t is the number of minutes after the injection. So we simply substitute t to get 2 times 3 over 3 plus 2 squared. 3 squared. And this simplifies to 6 over 12 or 0.5 mgl to the negative 1. Part B says find the rate of change of the tranquilizer after time t, c prime of t. So we c prime of t can be differentiated using the quotient rule, which says that in our formula booklet says that if you're trying to find the derivative of a function which is divided by another function, you find the derivative of the first function and multiply it by the second function and subtract the other one with the inverse, and then you divide by the second denominator function squared. So if we do this here, we have 2t derivative times 3 plus t squared minus 2t times 3 plus t squared derivative, and we divide all of this by 3 plus t squared whole squared. So now we just have to try and do this. So the derivative of 2t is 2 times 3 plus t squared minus 2t, and the derivative of 3 plus t squared is 2t, all divided by 3 plus t squared whole squared. So now this, expanding the brackets, we get 6 plus 2t squared minus 4t squared, all divided by 3 plus t squared whole squared. So now all we have to do is simplify this, which gives us 6 minus 2t squared all over 3 plus t squared squared. So that's part B done. And now the part C says, hence find the concentration of the tranquilizer when it is at its maximum. So that means that when the concentration of the tranquilizer is at a maximum, we will have a point at which the derivative will be equal to 0. So it will look something like this for a quadratic, or something like this for a cubic, so along those lines. So for part C, we simply have to find when the derivative is 0, and we have to interpret that point at which it is 0 and call that the and then find f of that value. So we know from the previous question that our derivative was 6 minus 2t squared all over 3 plus t squared squared. So we equate this to 0. Now we just have to input it into our calculator, and this will come out to be plus or minus root 3. So because time can't be negative, we can discard the negative root 3. So we'll have t equals root 3. The question here asks find when the concentration of the tranquilizer is maximum. So at t equals root 3 or at t equals 1.73 seconds, concentration is maximum. Alright, question 3 says the velocity of v meters per second of a particle after t seconds is given by v of t equals 0.3t to the 0.1 t plus 0.1 to the t minus 4. The following diagram shows the graph of v. So the question says find the value of t when the particle is at rest. So when the particle is at rest, the velocity is 0. We can see that it's at this point right here. So for part A, all we have to do is find 0 equals, and then we write the function of v of t. So 0 equals 0.3 p plus 0.1 to the t minus 4. Now we just have to put this into our calculator and solve. So 0.3 plus 0.1 all to the t plus 4, minus 4. And the calculator will give us the answer of t equals to 4.276 seconds. So t equals 4.3 seconds. Alright, now it says find the value of t when the acceleration of the particle is 0. So we need to know that the acceleration of a particle is the derivative of the particle's velocity. So we need to find the value of t when we need to find when the derivative of this function is 0. Now this graph is actually a bit tough to differentiate because it has t as the exponent, so we would actually need logarithms, but that is actually outside of the syllabus. So what we can do is graph the function onto our calculators, which will look something like this. Right? And all we have to do now is use the tangent function on the calculator. Try and find when the tangent gets really close to 0. And then when the tangent gets really close to 0, we would just round off that value and leave that as the and we just leave that as the answer. So we go to, on our calculators, F4, tangent, and we put in the value of 1. We see that the tangent is at 0.66 negative. So now we put in x equals 2, and that's gone positive. So now we do 1.2, and that's gotten really close to 0. So 1.19, and that's gotten really close to 0 again. So that means that our answer must be between 1.19 seconds and 1.2 seconds. So we can just put it as 1.19 seconds or 1.2 second. Alright, so now the next question says, consider the function y equals tan x minus 8 sine x. So we have the derivative as the first part of the question. So the derivative of tan x is 1 over cos squared of x minus 8 times cos x, as the derivative of sin x is cos x. So that's the derivative. Now it says find the value of cos x for which the derivative is equal to 0. So we equate this function here to 0. And we just input it into our calculators now, into the equation solver. So we go to solven 1 over cos x squared minus 8 cos x is equal to 0. And this gives us the values, different multiples of pi, but the closest one to us is pi over 3. So pi over 3. And we just take the cosine of this to find the value of cos x for which the derivative is 0. So we say cos pi over 3, which gives us 1 over 2. So at cosine is equal to 1 over 2, the derivative is equal to 0. So, question 5 says Frank is working on a computer animated film and he needs to realistically inflate a cuboid. This has a square cross-sectional area of side length x centimeters and a fixed height of 5 centimeters. The volume of the cuboid needs to increase at the rate of 20 centimeter cube per second. Find the rate that Frank will have to increase the side length when the side length is 3 centimeters. So let's just draw this scenario first. It has a square of x centimeters and x centimeters, and it has a fixed height of 5 centimeters. And so now we have to find the volume of this cuboid. The volume will be 5x squared. And here we are given that the volume of the cuboid needs to increase at a rate of 20 centimeters cubed per second. So we need to find the rates that Frank will have to increase the side length. So we have dx over dt is equal to dv over dt times dx over dv using the chain rule. So here we know that dv over dt is 20. So dx over dt is equal to 20 times dx over dv. And now we have to find dx over dv. So here it's given that the volume is like this, and we have to, and if we differentiate this function, we get that v prime of t is equal to 10x. So that means that in order to find dx over dv, we need to recognize that what we have found is actually dv over dx. Now to find the reciprocal of this, we just have to reciprocate this, meaning we have to reciprocate this. So we have dx over dt is equal to 20 times 1 over 10 times x. So we know that the side length is 3 centimeters. So if we just plug in that for x, we see that 20 times 3 over 10 is equal to dx over dt. And if we solve for that, we have the rate of change of the side is 6 centimeters per second. Right, let's move on now. Question 6 says the following diagram shows a vertical cross-section of an architectural interpretation of a traditional Tongan building, a fail. The cross-section of the thatched roof can be modeled by the curve 30e to the negative x square over 400, where negative 20 is less than x is less than 20. So this is the function that we are given. We can see that it's somewhat like a parabola, but it's not fully a parabola. So part A of this question says find the second derivative of x. Something that we will need to know is that the second derivative represents the point of inflection, or when the sign changes from positive to negative or negative to positive. So if we start trying to find this, we will be able to find the point of inflection. So f prime prime of x is given by derivating the function 30e to the negative x squared twice. So we have 30e to the negative x squared over 400. So the derivative of the outer function here is 30e times negative x squared over 400, because the derivative of e to the x is e to the x. And now the derivative of the inner function here is negative 2x over 400. So that would be f prime of x, but we're looking for f prime prime of x. So now we have used the chain rule to find the derivative of the first function. We now need to use the product rule to find the second. So we are given that the derivative is of 30e to the negative x squared over 400 is the exact same as the function, and we multiply this by negative 2x over 400, and now we add this with the derivative of negative 2x over 400 and multiply that by 30e to the negative x squared over 400. So that means f prime prime of x will be written as negative 60x over 400 e to the negative x squared over 400 plus negative 2 over 400 times 30 e to the negative x squared over 400. So if we simplify out this expression, we can just write it a bit easier as negative 60. Erase this as well. So negative 60 e to the negative x squared over 400. So what we can see here is that Sorry, I forgot an x. Yeah, so what we can see here is that we can factor out this negative 60 and simplify it, but that is not required as the question does not ask for a simplification. But if need be, it could be done. So part B says show that the gradient of the roof function is greatest when x is equal to negative 200. So the gradient of the roof function is actually what we have just found right here. And so we need to find the rate of change of the gradient of the gradient. So that basically means all we have to do is set this expression equal to 0. So we can see here that if we solve negative 60x over 400 e to the negative x squared over 400 plus negative 60 over 400 e to the negative x squared over 400 and set it equal to 0, which is when the derivative function will be the greatest, we actually get 10 root 2 or 14.14, which is the exact same as square root of 200. So that's part B. Part C of this question says the cross-section of the living space under the roof can be modeled by a rectangle CDEF with points negative a comma 0 and dA comma 0, where 0 is less than a is less than 20. So we have to find the function a of a for the rectangle CDEF in terms of a. So let's just annotate something. This is a, this is negative a. So the distance between these two has to be 2 times a. Now, at this point here, this is f of negative a. And this is f of a, which are equal, which means that this is symmetric about 0. If it is symmetric about 0, we're trying to find the area of the rectangle. So all we have to do here is say 2a times f of a, and we know that we were given the function as being 30e to the negative x squared over 400. So we say 2a times 30e to the negative x squared over 400. And multiplying this out, we have 60 ae to the negative x squared over 400 as being the area of the rectangle. So now part 2 says show that the maximum area of the rectangle CDEF is 600 root 2e to the negative 1 over 2. This question is actually a bit trickier than any of the ones we've had so far, because it involves a bit of outside the box thinking. So what we have to do in order to get this question solved is we can just plot the graph of what we had, the function that we had done before. We can't actually use proper calculus techniques to solve this off. So this x can just be written as a, and this x can just be written as a. So we have the function of 60a e to the negative a squared over 400 as our graph. So if we simply go into the calculator, type in 60x e to the negative x squared over 400, and then we find the maximum point, we see that y is equal to 514 514.6, so we can just jot that down. The graph looks like this, and this point is the maximum area at 14,514. So our maximum area will be 514.65. Now, this is the decimal equivalent of the expression given in the question here. So we have shown that it is the maximum possible area. Now part D says function I is known as the insulation factor of CDEF. The function is defined as I of A equals P of A over A of A, where P is perimeter and A is area. Find an expression for P in terms of A. So we know that the perimeter of a rectangle is equal to 2 times the base plus 2 times the height. So it'll be 2a plus 2 times 30e to the negative a over 400 squared. So that's what part D will look like. And part D2, it says find the value of a that minimizes I. For this, we simply graph this function onto the calculator again. So all we must do here is graph the P of A divided by the A of A. Graphing P of A will give us 2x plus 2 times 30e to the negative x squared over 400. And this gives us a function that looks something like this. And the minimum point occurs here. So we find the minimum point, and the value of a that minimizes it will be 15.04. And that is our answer for part 2. So the last question here is consider the two functions f and g and their derivatives f prime and g prime. The following table shows the values for the two functions and their derivatives at x equals 1, 2, and 3. Given that p of x equals f of x times g of x and h of x equals g of f of x, find p prime of 3 and h prime of 2. So to find p prime of 3, we simply must use the product rule. So at 3, we know that p of x is equal to f of x times g of x. So if p prime is equal to f of x times g of x, then at that point we will have to find f prime of 3 times g of 3 plus g prime of 3 times f of 3, and we just have to substitute these values in now. So f prime of 3 is equal to 2, g of 3 is equal to 4, and g prime of 3 is equal to 3, and f prime of 3 is equal to 2. So all we have, that was a misread, it's equal to 1. So all we have to do now is just solve this, which gives us 2 times 4 plus 3 times 1, which is equal to 11. Now part B says that h prime of 2, and we know that h is g of f of x, so that means we must use the chain rule here. So so this means that we will be finding g prime of f of x times f prime of x. So f of x here is 3, so f of 3 is what we are given as 1. So g prime of 1 is what we're looking for here, and that's 4. So we multiply that 4 by f prime of x, where f prime of x is equal to 4 as well. So we simply find that it is equal to 4 times 4, or it gives us 16. So the answer is 4 times 4, which is equal to 16. I hope you found this practice test, the solving of this practice test helpful, and have a good rest of your day.